Hi Vishnu Ram, are you okay? Okay. You feel very tired?
No.
No? Okay. கொஞ்சமா குத்துங்க நான் கொஞ்சம் குத்தினேன். Hi Sham, how are you?
I'm good.
How are you aligning our curriculum to your curriculum, Sham? It's
Um,
interesting, right?
yeah,
Yeah, how are you doing it?
I don't know.
How are
I'm
you
doing good.
managing?
At first, it was kind of hard, but now it's easy.
Easy in the sense, are we doing things before your school?
Not really, but no, yeah. Some things before my school, not
Some
all
things
the
before.
things.
Okay, what are the things not before school, Sham?
Um, uh, like
Hmm?
and angle bisectors, like those things.
Oh yeah, I see. Angle bisector will come, mama, but a little later, very soon. Meaning next chapter we have isosceles and equilateral triangles with angle bisectors.
Okay.
Yeah. How are you, Ashwik? Ashwik, when are you going to CB, Ashwik?
Huh?
When are you going to
Maybe.
accelerate? Huh?
I don't know. I have to check.
Oh my
I
goodness.
didn't do it yet.
Hey, Priyanti.
I know, right? Your case is a very special case, I'm saying. You have to accelerate. It's high time you accelerate.
Yeah.
I know. That's okay. Have fun. Have fun at school. Vidyut, how are you?
I'm good. How are you?
Good.
hmm
You doing your homework, Alchemist?
Yeah, I did the Alchemist.
That's good. How about Ritish? Are you doing the homework, ma?
Yeah, I just couldn't do I did the Alchemist, I didn't do the constructions because I had science and just like this week and next week, so I had to study for that.
Oh, I see. I see. But do, ma. That only will keep you up.
Oh, do I do it on how do I do it on the paper though? Because I remember you said do it.
Yeah, on the paper, right? With the compass.
Oh, I have to get okay.
You have to get it feels hard to think about it, but definitely do it. You get it?
Okay. Yeah.
Okay, we'll go. Yeah, I think we'll go. We'll get to the directly. Then only we'll be able to complete some before summer. Okay, let's see. One second. Okay, so we did not do congruent triangles, congruent triangle. Okay, two shapes are similar when two shapes are similar. Two shapes are my gosh. One second. Wow. One second. Yes. I'm glad I didn't misplace. Two shapes are congruent. Let's say this triangle is congruent to this triangle, right? We call this as this. Any questions here? Any questions here? Can I move on from here? So we discussed a lot of constructions last week, right? Okay. Now, suppose, let's say when this side of a triangle is equal to, let's say, A, B, C, D, E, F. In this case, let me ask you, AB is congruent to DF, BC is congruent to EF. Okay. AC is congruent to DE. How do you describe the congruence of the triangles? Okay, I'll ask you this. ABC is congruent to what? Come on, guys, I want you to try. ABC is congruent to what?
Is it DEF? Oh no, wait.
The DFE.
DFE, good job. You
Mhm.
got it? Okay, so basically, when the three sides of a triangle are congruent to three sides of another triangle, then this is called side congruence. Meaning, this thing, right, telling that when the sides of a triangle are congruent to another side, to the other three sides of a triangle, they're congruent. Saying like this, right, you don't ask me for proof, okay? Yes, when you draw this side, congruent to, let's say this side you draw congruent to this side, let's say you draw this congruent to this side you draw congruent to this side. In this case, if you draw it like this, right, automatically the two triangles will look the same. So we call this, you just accept it, meaning you just take it as an accepted fact without asking for a proof. So what do I call this SSS congruence? There's a name for it, remember? Statements that are just accepted as facts.
Axioms.
Axioms, good job. Axioms are, I call this as a postulate. SSS congruence is a postulate. Usually, there has to be something which we accept. If not, how do we prove? We have to have some facts that we have accepted, right? So this SSS congruence is a postulate. You got it? In congruence area, SSS is the only postulate that we accept as is. The rest of it, right? Okay, there are so many types of triangle congruence. Okay. This is triangle congruence, right? You have SSS. What are these? Can you describe what are these? What is this? Anish, do you want to say what is that?
What?
What is that, ma?
I didn't
No. What can this be? I told you that this congruence is the only postulate we'll have. Right? What is this SAS? What can be that SAS? This is side, I told you.
Side, angle, side.
Yeah, side, angle, side. So,
Next one's angle, side, angle. And then
correct.
Side.
Yes. So, side, angle, side. If one side of a triangle is congruent to another side, but be careful here. The another side is congruent to another side. Which angle you should take? The angle is sandwiched between the sides. So, which angle it should be?
The one in the middle.
Yeah, that is far more important than anything. You got it? So here, B and E dash should be congruent. The sandwiched angle between the two sides should be congruent. You got it? But this one will trick everybody. Okay? ASA is angle, side. Okay, now coming to this angle and this angle, which side should be congruent? Which side should be congruent? Which side should be congruent? This side. Do you see it? The sandwiched side.
AC and DF.
Yeah, AC and CF here. Yes. You see it? The sandwiched side should be congruent. How about AAS? Angle, side. Do you see it? Let's say this is not the angle, side. You see it? Okay. So, I have just given you an intro of the different types of congruences. Let's see, wait. Now, last week we did some constructions, right? So, how do you think you can draw this? Okay. AC, wait, let me give you. Basically, this is how I wanted to introduce it to you, but I did not. Let's see. Wait, I want to go back. AC is equal to 2.5 centimeter. BC is equal to 3.5 centimeter. Okay. Now, AB I want, right? Hold on. AB. Okay. AB is 4 centimeter. How to draw this? So, I'm going to first draw starting here. AB will be 4 centimeter. Now, I have to find let me tell you this. You're going to tell me how am I going to get it up. I want to draw BC. Okay, I want to draw BC in such a way that that C point is 3.5 meters away. And I should also ensure AC distance is 2.5. So what do I do? What can I do to get such sort of a figure? I don't know angles. What can I do? How do I draw this? Try, guys.
We find the locus of all points. That could be 3.5 centimeters away.
Yep. From A, I will find the locus of all points that are 2.5 centimeters away. Then what does it form?
A circle.
Yeah, a circle. I will find the locus of all points. So I will draw a circle that's 2.5 centimeters in 2.5 the radii. Yeah, this radius is 2.5 centimeter. So this radii will be 2.5 centimeter. You see what I mean? Now, at the same time, what should I do for BC? I will, with this as center, with 3.5. 3.5 is my radius. 3.5 is my radius. I'll find the, oh my gosh. I'll find the locus of all points that's 3.5 centimeters away. You got it? So this is 3.5 centimeter. If I do that, then this intersection, right? This is my triangle. Does that make sense? So this is 3.5, this is 2.5. Anish, did you get it?
What does locus mean?
Okay. Locus of all points means this is the locus of all points. Locus means the path traced by all of the points that are exactly 2.5 centimeters away from A.
Circumference?
Locus doesn't mean circumference. Okay, locus of all points means you are going to trace through through all the points that are 3.5 centimeters away. Does that make sense? Does it make sense to you? So locus is a singular form. Loci is the plural form. Okay. But locus, English meaning, right? It will just point to a specific location, particular place, like that. You got it?
Yeah.
So that's what locus means. But locus of all points means all those specific points together when taken into consideration. You see what I mean? So locus of all points that are exactly 2 centimeters from a point will become a circle, correct?
Yeah.
Did that make sense?
Yeah.
Okay. Now let's see. Where are we? 1 second, guys. So this is how I drew the side triangle. First of all, you should know how we draw the side triangle without the angles, right? I will start drawing the first one and then I'll find the locus of all points from B and then find the locus of all points from A. The intersection will form the triangle. You got it? So this is symmetric. When you move this circle to that circle to this side, the same thing will happen. Any questions? Any questions? Okay. Now let me quickly give you a problem based on last week's and stuff. Okay, if we keep on discussing this, you will go mad. Let's see. Okay. Now this is 17, 9, 9. This is 25. Now find MLN.
What?
1 second.
What's M, L, and N?
Yeah, I'll give you, but wait. I don't think I'm finished with the problem. Hold on. Okay, that's it. That's my question. Okay. Please let me go ahead with this, okay? There's no way you can do this. Can I go ahead? Okay. What do you think this is? Any thoughts?
25.
True, but how do you say that it's 25?
They're
I
like,
didn't say that LM is parallel to. I didn't
oh,
say that LM is parallel to ON. See, there's nothing. See, that's what is hard about geometry. Meaning, without them explicitly telling, I cannot assume from the diagram. So that makes it hard. Unless I prove LM, and ON are parallel, I can never prove that the angles are equal. Does that make sense?
But
if they
can't you
weren't
say like
parallel, but
that?
then
What is it?
if they weren't parallel, then wouldn't 9 like not be equal to 9 because like one of the lines would be angled?
And also the hypotenuses also equal each other.
Okay, but okay, how does that say? You see, there is nothing to prove that they are parallel, correct? So let me show you something. I hear you. Okay, this is 9, this is 17, you're saying, right? Yeah, this is 9, this is 17. Perfect. That's the way to prove. But so what? You see what I mean? So what? So everywhere it requires a proof. First of all, for me to say that this is 25 and alternate interior angles, you clearly found out that. I'm amazed actually. You have to first prove that these two lines are parallel, correct? Okay, now let's go ahead. Meaning for anything and everything we'll start proving. Okay, in geometry, when it comes to proofs, right? We will start with two column proofs. Two column proofs, and there are flowchart proofs and paragraph proofs. I don't paragraph proofs. I don't remember how much of emphasis this particular book gives to all the three types of proofs. Definitely, proofs are important in this book, and the one particular proof type that we will concentrate on is the two column proof. The only difference between these is the structure in which we write the proof. Whatever we write in here doesn't change. Okay, so here we have a statement, we have a reasoning. The book doesn't introduce you to this till now, but I'm going to go ahead. We are going to discuss this. Okay, so this is a two column proof. Okay, the same proof statements when written as a flowchart, it's a flowchart proof. Okay, the same whatever I write in here, if I write it as a paragraph, it's a paragraph proof. Ashwik, are you okay? Ashwik, can I move on?
Yeah.
Okay, so when you think about it here, right, first I start with, okay, always in a two column proof, it starts with what is given. What is given? LM is equal to 17 and ON equal to 17, right? And then you'll say OL equal to MN equal to 9. All this is given. You're a layman, okay? You have to make a layman understand, meaning you have to make a kindergartner understand your proof. So I'll start with what is given. Okay, now I can also say NL is again congruent to, I can say congruent. I'm a geometry person. I don't want to say equal to. And then okay, NL is congruent to LN. Why? See, the reasoning, right? I want you to introduce you to this reasoning piece a little differently. For now, I'll go ahead and say, okay, the reasoning is symmetry property or reflective property.
So 9 is equal to 9?
Yeah, 9 equal to 9, right? See, here as well, here it is given, but it is given that they are equal. It's not given they are congruent, first of all. I am a geometry person. I want to use congruence, okay? But they have said that they are equal. The length of the line segments are equal. That's what we know. Okay, but when I say they are congruent, right, I can as well write another step. LM is congruent to ON, and what else? LO is congruent to MN. Like that you can change. Then you can say the definition of congruence. I know, guys, I have not introduced you to what all reasoning you can write. So this is meaning I'll just introduce you to one proof. Okay, don't worry about how to write reasoning and stuff. I'll go back and I'll tell you these are the reasons you can start writing for a proof. Okay, I'll go there. I'll provide a separate assignment on that. Okay, so definition of congruence. Now NL equal to LN. See this one, right? This is equal to the other way. That is reflective property. Now with this said and done, right, we have proven that this is congruent to this, this is congruent to this is congruent to itself. What does it mean to the two triangles? You tell me. What does it mean to the two triangles? What does it mean, guys? Now only we studied, right? This is equal to...
SSS congruence.
SSS congruent. So I can say LMN is congruent to
O
N.
O L N. Wait. O L
LMN is
Oh.
congruent to
O-N.
OM.
LON.
No, yeah. See, LM is not. Amma, whenever you say the order, geometry, it's so picky, choosy. Okay, if you make a mistake, it's a mistake.
N-O-L.
Correct. LMN is congruent to what? It starts with a 17, goes to a 9. NOL. Make sense? So the order is very, very important. Here you know what it means, the order. First two letters. LM is congruent to NO. MN is congruent to OL. Don't worry about the reasoning piece. Okay. Reasoning you can't write. Okay. And you might be thinking, what is this? How am I to write the reasoning? Don't worry about it. I'll come back to that. Okay. But see, this is how we prove is what I want to show you a taste of what is a two-column proof. Okay, now the reasoning, you'll say SSS congruence. But that does not prove that this angle should be equal, right? There is one special thing that we can use in geometry. If you prove two triangles are congruent, right, then that means that every angle of them is congruent to the other angles of the other triangle. Meaning, see, this angle L is the same as N. Make sense? Wait. This angle L is the same as this N. Similarly, M angle, which is the M angle, let me put it in different colors. M angle is this, is the same as O, the middle letter. And then N, what is that N for that? That N, this angle is the same as L. Does that make sense? They're equal means I can say that they are congruent. Make sense? Okay, so, but the thing is, when the triangles are congruent, right? Using SSS congruence, we say that the two triangles are congruent. But there is one another term. Corresponding parts of congruent triangles are congruent. This is a very famous thing in geometry. This says corresponding parts. Dia, are you following?
Yeah.
Corresponding parts of congruent triangles are congruent. What does it mean? Tell me. Suppose let's say A, B, C. Okay. You know
The
that
parts of the triangle are congruent, that means the angles are congruent.
Corresponding parts of congruent triangles are congruent. What does it mean?
So if the parts of the triangle are congruent, that means that the angles are congruent.
If the two see, congruent triangles is what we have come across. Using SSS congruence, we proved that they are congruent triangles. Okay. So what does it say? Corresponding parts. This part is the corresponding part of this part. For the congruence, ABC is congruent to DEF. AB is congruent to DE. BC is congruent to EF. Similarly, AC is congruent to DF. However, these are the corresponding parts I am explaining. However, angle A is congruent to angle D. Okay, and then the next one, angle B is congruent to angle E. The next one, angle C. These are corresponding parts I am explaining of the two triangles. What are corresponding parts? The related parts of the two triangles. Meaning A is related to D, B is related to E. The order is important, guys. Again here, whatever order you write, it's very important. Okay, you cannot say ABC is congruent to FED. You got it? It's a blunder. So the corresponding parts of congruent triangles are congruent. Using that, in these two triangles, you can clearly say what? ONL is congruent to MLN. What does it mean? Reasoning is corresponding parts of these two are corresponding parts. When you think about it, right? This part and this part, they are corresponding parts of congruent triangles. They are congruent. That means it tells you that MLN is equal to 25 degrees. Why? Given, reasoning is given NML is equal to 25 degrees. Makes sense, guys? Don't worry about writing proof. Okay, for now what you need to worry is, okay, triangles are congruent. Then you can always call them as SSS, SAS, like that. There are several congruences that you understand. We covered only SSS congruence, and I told you how to find out whether it is SAS or ASA, like that. However, what you need to understand big is SSS congruence and CPCTC. Corresponding parts of congruent triangles are congruent. Make sense? Does it make sense?
Yeah.
Okay, great. Okay, so you need to remember the CPCTC. Okay, CPCTC means in geometry. It's a very, very, very popular term. Corresponding parts of congruent triangles are congruent. Okay, now let's see this one quick. Okay. You know what is bisect? Sham, you were the one who asked at the beginning of the class, right?
Exactly.
Yeah.
You know what is bisect? Huh?
Parts.
Bisect. What is bisecting?
A bisect means passing through.
Is it
Splitting
possible?
something in half. Or
Bisect, cut into two. Two cut. Cut into two. So such that this part is equal to this part. Exactly cut into two equal halves. Make sense? Okay, now let's see. I don't know what is this proof is. Let's see together. Okay. Now, radius of a circle bisects a chord of the circle. What you need to prove is radius of a circle. Radius of a circle bisects chord of the circle. That is not the diameter. Then, okay, it goes like this. If the radius of the circle bisects, this is a chord, okay, bisects the chord, bisects this chord, bisects the chord of the circle. This chord is not the diameter of the circle, is not the diameter. If the radius of a circle bisects the chord of the circle, that's not the diameter, then you have to prove that the radius is perpendicular to the chord. Radius is perpendicular to the chord. You see, guys, do you understand what it is asking for? So we have to prove that the radius is perpendicular to the chord. How do we do this? Okay, let's try this. What do you think? We are not going to get into big proofs, but try. How will we prove? Think about it. How will we prove this? Guys, you are going to tell me. Think about it and tell me. We studied some reasoning, right? We studied what? SSS. There are different types of congruence. You can call it as, you can put it in reasoning. And we also studied about CPCTC. So based on that, do you think you can tell me some proof to prove that the the radius of a circle bisects chord of the circle, then that is not the diameter, then it is perpendicular to the chord. Can we try that? Guys, you're going to prove. I'm not going to prove. Statement reasoning. I'll write it here. I will help you with reasoning, but you have to come up with start thinking about what we should write first. Go ahead, guys.
What if we make a right angle?
Yeah, that's what you need to prove. The radius is perpendicular. You need to prove that AMO and BMO is 90 degrees. That's what you need to prove. How will we prove? Somebody start, please. Vishnu Ram, why don't you try?
I don't know. Like, can you like explain?
Bisect means 2 equal parts.
Yeah, 2 equal parts, correct.
So
Well,
then technically,
Since we know that OAC and OBC are kind of congruent because it's like 2 and 1, like I don't know, they're congruent angles. We could say that it's a straight line. Like, I don't know how to explain it. This part here.
Yeah, you're coming there, but before that, I want to
does C bisect?
Okay, ma. Let me answer Ritisha. Ritisha.
Yeah.
Yes, it can be like this, Ritisha. This can be a straight line. Okay. This can be a straight line. Now, let's say here, OBCA. If it is like this, right? OBC, I can't say is 90 degree. And CBA, I can't say it as 90 degree.
Okay.
You see what I mean? I understand. That's the last part of our proof. You're saying since this is 180, right? You're splitting up into 2, right? But it need not necessarily be 180. It can be like this or it can be like this. You see what I mean?
Yeah. Okay.
So just by seeing, again in geometry, you cannot come to the conclusion it's 90 degree unless somebody tells you. So we need to prove that that is 90 degree. That's true. 90. But how?
Priyanti, this is just like an idea, but what if like triangle OAB, because it's isosceles, like when you split it in half, it's right angles.
True. See, that is the reality. But how to prove that? We studied congruence, right?
Yeah, but like C bisects both of them, and bisects means like.
Correct. C bisects. OC bisects. But how will you prove that it? Okay. Yeah, OC bisects. So what?
Bisects means 2 equal parts.
Correct. So what do you say?
So it's equal parts.
What are equal parts?
AOC, AOM, and OMB.
Mama, AO. Okay.
So like both the triangles are equal.
We don't say triangles are equal, right? Geometry is very picky, You can't say triangles are equal. Okay. I said we have to start proof with what is given, right? Statement says radius OM bisects AB given. Correct? Amma, I am a kindergartner. Okay? I start from the given. From that, I need to conclude something. What I can conclude? From this statement, I have to conclude something. What I can conclude?
That OM splits AB.
Correct. So what I can write? See, I am a kindergartner. I will start with what is given. Literally, I wrote this there. Okay? From here, next step I have to derive. It's a proof is nothing but a logical sequence of statements. Logical sequence means from the previous statement, what is the next statement I can write? Radius OM bisects AB. What does it mean? What does it mean?
Well, then AM and BM are both
AM is
equal to B.
Congruent to BM. Can I say that?
Yes.
Good. Okay. Definition of, I can say this is the definition of bisector. Okay. And after that, now we proved that, now we know that these two are equal. AM is congruent to BM. Then what?
A, B, and AO and BO are equal.
Very nice. Why AO and BO are congruent?
Because A, M, and BM are both starting at the same point and like equal to that.
Why AO and OB are congruent? Why would they be equal?
They have two lines.
Huh?
Like there's lines. Like
They are lines, but what lines are they?
these.
Perpendicular. No.
AO and OB, what lines are they?
Congruent lines?
Why are they congruent?
Because they start at and end at the same point. Wait, 1 minute.
Radii of the circle. Radii are congruent, right?
Yeah.
Yeah, they both are. This is one radius, this is one radius, right?
Yeah.
Right. Now, what do you think about OM? OM is congruent to MO, reflection property. So, with all this, what can I say? I am a layman, I am a kindergartner, right? I said AM is congruent to BM, AO is congruent to BO, OM is congruent to MO. So, now what can I say? I said AM is congruent to MB, then AO is congruent to OB, then finally MO is congruent to OM. So, what can I say?
OMB and AOM are
Good job.
equivalent.
OMB and
AOM are equivalent.
OMB and OMA. Order is important. They're congruent. Why? What is the reasoning?
Was that if
What is the reasoning?
OMS are equivalent and
SSS congruence. Nice. It takes time. I do understand. I'm not expecting you to be right off. SSS congruence. Okay. Now what is it we need to prove? We need to prove that the radius is perpendicular to the chord. So how do we prove? Go ahead.
we could use the Pythagorean theorem to calculate
No. We can't, meaning you don't know the lengths, you know nothing. But remember, we talked about something. What is this? Corresponding parts of congruent triangles are congruent, right? What do you think about AMO and BMO? Angle AMO and BMO. What do you think about those two angles?
right angles.
We can't say they are right yet.
They're equivalent.
Yeah, they are equivalent. Why? Because that is a corresponding part of congruent triangles. You got it?
Yeah.
These two are corresponding parts of two congruent triangles. Does that make sense?
Yes.
Okay, so they are equal, we have proven. Now, what is this line AB? AB is a straight line, correct? Given. So, what can you say about the
180
angle?
degrees.
AMB angle is, I don't know how to write this angle. Yeah, AMB is a
180
straight, AMB is equal to 180 degree because it's a straight line.
And then because OM is bisecting.
Exactly. We know that these two are equal. So AMB is equal to OMB is equal to 90 degrees. Does that make sense, guys? Dia, did it make sense? I am not expecting you guys to be right on toes with the proofs right now. But this is how you start writing proofs, and writing a proof till you get a hang of it to start writing, it feels difficult, but it comes only when you try. Make sense?
I feel like a paragraph would be easier.
Which one?
I feel like a paragraph would be easier.
Really?
Yeah.
Okay. See, so this is a 2-column proof that we are writing, okay? Meaning, I'll go ahead and explain this peacefully. Okay, then you will get more confidence in writing the proof because you know more reasoning. Okay, just because you're not knowing reasoning, you feel like you're stuck, you don't know what to do next. But for the left column, right, it's very easy. If you start with what is given, write it down. The next step is a sequential, logical sequence of the before step, of the previous step. Radius OM bisects means explain what is bisect in terms of geometry. AM is congruent to BM, right? And then AO is congruent to BO. You can observe that the radii are equal. It always boils down to some sort of congruence. And then CPCTC. So these are common ways that you can think about the route for proving. Make sense, guys? Yeah, you don't have to be able to reproduce it. Okay, I'll come back to this reasoning. Give me a few minutes. So now, when we discuss congruence, right, where are we on congruence? One thing is, what I wanted you to know was, these are the congruences that are there. SSS, SAS, ASA, AAS. Got it, guys? There is no AAA, please. There is no AAA. Does that make sense? I really want you to understand SSS, SAS, ASA, AAS. Yeah, now these are the 4 types that are in there. Okay. But wait, I want to do a little bit differently. Not follow the same book completely. Hold on. You're going to give me 2 minutes, okay? Now let's see. What should I do? I want to go to my drive. I will go here. I don't know, where did we start proofs? Okay, these are the postulate proofs. See, this algebraic proofs I want you to know. Yeah, see guys, I don't want to enter into the book proofs right away, okay? But I really want you to understand all of this and then only move on to proofs, okay? So I'm going to bring this in between. This is not in the book, okay? But I really want you guys to understand these, okay? There are some postulates in geometry. I told you, right, accepted statements in geometry. I would like you to know that first. Okay, now these are some postulates that you should be knowing. Okay, without this you cannot prove anything. Okay, only if you know some postulates, some accepted statements, you can prove. Okay, so the first postulate says through any 2 points, there can be only one line. These are some basic statements that we accept as true. Second postulate says through any 3 non-collinear points, there can exactly be one plane. See, a plane is defined by 3 non-collinear points. Through any 3 non-collinear points, there can be exactly one plane. What is non-collinear? 3 points that do not lie on a straight line. Through any 3 non-collinear points, there can be exactly one plane. Then a line, right? Any line contains at the minimum 2 points, right? A plane at the least contains 3 non-collinear. There can be more points, but minimum to define a plane, you should have 3 points. Make sense, guys? And what? If 2 points lie on a plane, then the entire line containing these points, if 2 points lie on a plane, then draw a line joining these 2 points, then that line also will be on the plane. Vidyut, are you here or you're gone? Ashvik, where are you?
I just went to
Here.
the bathroom, Auntie.
No problem. Ashvik, how about you?
I'm here. This is my camera. My camera isn't working because I don't have any internet here. I'm outside.
Okay, if 2 points lie on a plane, then the entire line containing the points also lie in the plane is what we studied just now. Then, if 2 lines intersect, two lines intersect, you find the formation of one point. Two lines, when there are two lines intersecting, then the intersection is exactly a point. If two planes intersect, what would happen? If two planes intersect, right, their intersection is a line. If two planes intersect, let's say, two planes should intersect, right? This is a plane. I'll draw another plane like this. If two planes intersect, right, the intersection, see, this is a line, right? Makes sense, guys?
Yeah.
So these are postulates that you have to know. Okay. From the postulate, see, a plane is always defined by three non-collinear points. You should know that, guys, slowly. Okay. Now, let's see this one. How about this? Okay. Okay. This book goes a little differently. The way we go through school geometry is a little different though. Okay, let's see. Okay, you're going to answer these for me. Okay. How about this? Answer these for me. We studied some postulates. Determine whether each statement is always, sometimes, or never true. There is exactly one plane that contains points A, B, C. There is exactly one plane that contains points A, B, C.
It's always true.
Huh? What do you think about this statement? Always, sometimes, or never?
Sometimes.
Sometimes.
Why? Correct. Sometimes is correct. But
Sometimes.
why? Why?
Because you can make multiple planes with those 3 points.
You're saying sometimes, right? What are the times that this is true and what are the times it's not true?
Because that like it says any 2 points there's exactly one line.
Amma, there are 3 points.
Yeah, but like what if 2 of the points make one line?
So what do you call them?
And then
You're right, but what do you call them? Okay, you're saying the 3 points are there, 2 of the points make up a line, you're saying, right?
yeah.
Yeah.
We're saying
So
two of the
in
points are
2.2
linear.
it says
what is that? Good job. What is that?
2 of the points are linear. I can't say it right. Linear.
I know. When the 3 points can be collinear or the 3 points can be non-collinear. When the 3 points are collinear, what happens? When the 3 points are not collinear, what happens?
The 3 points are collinear, it forms a line, and whenever it's not, it doesn't.
No. There can be many planes that contain the 3 points. There can be many planes that contain the same 3 points if they are collinear. You get it? The same line can be contained by many planes, right?
Yeah.
Whereas when the 3 points are non-collinear, there has to be only one plane because that's the definition of, that's how, meaning 3 non-collinear points defines a plane, right? So when the 3 points are non-collinear, there's always only one plane that covers all the 3 points, that contains all the 3 points. You got it? So when the points are collinear, this is not true. When the points are not collinear, this is true. Make sense, guys?
Yeah.
That is why it's sometime. Yeah. See, when we get started with geometry, it feels a little different than algebra, but then you'll enjoy slowly. How about this? How about this? Points E and F are exactly contained in exactly one line. Point E and F are exactly contained in exactly one line. What do you think about it?
Isn't it like the 2.1 postulate?
Sorry, Ma, what is that?
Isn't it like the 2.1 postulate?
Correct. So, sometimes always, correct. That is the 2.1 postulate. Very nice. So, what do you think about it? Is it always, sometimes, or never?
Always.
Always. It is a postulate. You already found it out. So, it is always true. Can I go ahead?
Yeah.
Yeah, that's nice. Let's see. Let me go ahead and do one more, maybe. Okay. How about this? How about this, guys? It takes time, and if you didn't get it, it's okay. Let's do it as a class. Slowly, you'll get it. Go ahead. Two lines intersect in two distinct points M and N. Somebody else try. Always, if you already know, don't say. Let the others say. Let the people who are confused, let them say and find out.
I'm gonna close the door.
What do you think about this? Two lines intersect in two distinct points M and N. M and N. What do you think?
Is it never?
Never. Why? Why? What is the postulate corresponding to that?
Is it could only intersect at one point?
At a point, yes. That is the postulate. That's an accepted fact. But this one contradicts that postulate. So, two lines intersect in two distinct points. Two lines can always intersect at only one point. Two planes intersect in a line. Got it? Yep. Now, let's go ahead. You can work on this more in the homework, okay? See, but the problem is you don't know what is a converse. Oh my gosh. Okay, let me see this one. I'll just introduce you to the definition of converse, okay? Okay. In geometry, right? Every week we will study new definitions in geometry. At least one new definition in geometry will be there for the next several weeks, okay? You call something as a conditional. You know, if-then statement. Have you heard of if-then statement? If, you can say in geometry, right? If A is equal to B, then B is equal to A. If angle A is equal to angle B, then angle B is equal to angle A. This type of statements are called if-then statements. Make sense, guys? Now, yeah. Now, if-then statements that we say in English are called conditionals in geometry. Any questions? If-then statements that we say in English, they are called conditionals in geometry. Okay. Let's say if a number ends with 2, then it's an even number. This is an if-then statement in English. This is called a conditional in geometry. Now, you have two parts of an if-then statement, right? The if part is there. The second part is the then part. Any questions still here? Okay. Now, the if part is termed as the hypothesis. The then part is called the
Evidence?
conclusion.
Or evidence?
Conclusion. You conclude, you make a conclusion, right? Then it is an even number. Make sense, guys? I will call P as the hypothesis, Q as my conclusion. Make sense? Now, how do I write a conditional? When I write a conditional, this is a conditional. I can refer it like this. If P, then Q. That is a conditional. Make sense, guys?
Yeah.
Now, every conditional has a converse. You know what is a converse?
An opposing side.
Yeah, but how do you define it? Now, can you tell me what is the converse from this conditional?
Something.
See, I told you conditional is if P then Q. Converse is if Q then P. So, how do you rewrite this conditional as a converse?
If
Is it
it's
like if it's an even number, it ends with 2.
Exactly. If it's an even number, it ends with 2. You see? Okay, but there's a glaring doubt now. If a number ends with a 2, then it is an even number. You all agree with it?
Yeah.
So, the truth value of the conditional is true. You all accept it. But you also said, hey, the converse is if it's an even number, then it ends with 2. This is the converse. I know that, but what is the truth value of this converse?
Not all
Sometimes-
even numbers end with 2.
Yeah, it's not always true. Correct, guys? So the truth value of a conditional and converse may not be always the same. You got
Yeah,
it?
but it says if a number ends with 2. It doesn't specifically state that only numbers which end with 2.
Oh, yeah. So if a particular number ends with a 2, yes, then we call it as an even number. That is true. But if it's an even number, then it ends with true. That is not acceptable. You see, there can be other digits ending. So, you see, what I meant to say, what I wanted to show you today was, what is a conditional? What is a converse? So, when you switch your conclusion to hypothesis to conclusion, it becomes a converse. Make sense? That's it. And you refer to it by this, right? And we also explained what is the truth value of a conditional, what is the truth value of a converse. Truth value of a conditional may not be the same as the truth value of a converse. Any questions? Any questions? There's more to it, guys, but I'm not dealing with too much of detail right now.
No.
Okay. We should also find out what is an inverse and a contrapositive. We'll do that later. Okay. I don't want to push with too many new things. Okay. Now postulate you can do by yourself. Other than that, see, this one last week I wanted you to introduce. Without this, you cannot write proofs. Okay. So, here. See, guys. This is the first set which will help you write the reasoning in 2-column proofs. You see here? Now, whenever there are some properties of equality, which you should know. Okay, what is this property of equality? If A equal to B, if A is equal to B, then you can add C to both sides and say then A plus B equal to B plus C. Does it make sense? So that is addition property of equality. Now, if A is equal to B, then A minus C, you subtract C on both sides, that's subtraction property of equality. Well, if A multiplied by C, if A is equal to B, then A multiplied by C will be equal to B multiplied by C. This is multiplication property of equality. Similarly, A equal to B, you divide by C on both sides and say, if A equal to B, then A by C equal to B by C. C is not equal to 0 is important to say, because if C is equal to 0, then the entire thing becomes undefined. So you will have to specify that C is not equal to 0. Wherever there is a denominator, you cannot have the denominator as 0 in mathematics. So you'll have to specify that C is not equal to 0. So that is division property of equality. What is this reflexive property? Sometimes we say, right, AL is equal to LA. That is reflexive property. So A is equal to A is the reflexive property of equality. Symmetric property says A is equal to B, then B is equal to A. Pa, hard pack okay pa. Hard pack nahi hoega pa. Sorry guys. If A is equal to B, then B is equal to A. The opposite, the other way of telling symmetric property. Okay. Now guys, these two are so similar. I really want you to understand what is the difference between them. A is equal to B. See, we are making a chain, you see, and B equal to C. There is a chain here, you see. Then A equal to C is transitive property. Does that make sense? Transitive property, there is a chain. Now, A equal to B and A equal to C, then B equal to C. That is substitution property. Make sense, guys? There's a difference between the two.
Yeah.
Here you are making a chain. A equal to B, B equal to C, then A equal to C. These two you are equating. Here A equal to B, A equal to C, then B equal to C. That is the substitution property. Make sense?
You're not replacing a variable.
Yeah, you're replacing a variable. Correct. In substitution, you're replacing a variable.
In
And then in transitive, you're making a chain. And then A of B plus C is AB plus AC. Make sense? Make sense? Okay, these are the properties of equality. We learned a lot today. Now, let me see. I don't know whether I can give you this homework today. Okay. Now, no, I'll stop here, guys. Okay, but you know, if I want you to prove this I want you to be able to write proofs like this. This is very easy on you. To start with, we don't want to start with harder proofs. See, given they've given this, right, guys? You have to prove x equal to -2. This is just based out of algebra. From algebra, we derived all this. So when you write the proof, right, this is given. See, you start with given. This one I'll give it to you for homework. And then the next one, what you can do? You can subtract x on both sides. Subtract x on both sides, subtraction property of equality. Then again subtract 8 on both sides, subtraction property of equality. Now what do? You divide both the sides by 3, x equal to -2, division property of equality. So this is what you need to prove. Make sense, guys?
Could you put this in like the thing?
No, I'm going to give you notes on this. The same notes I'm going to give you. Don't worry about it. I'm going to get you notes and then you follow that, write out proofs. Okay. Make sense? Does it make sense? So this is the proof that I want you to write for this week. Let's not get into geometry. We are coming from algebra 1. So these are the properties of algebraic equality. These are the properties of algebraic equality, which we discussed now. So from these properties, again you are going to be given algebraic statements that you will prove first. Okay, but what I showed you today was an example of a real geometry proof we'll do. We will do tons of proofs like what we did today, but that's a little hard and far. So that introduced us to 2-column proofs. So now we are trying to build from algebra and start writing 2-column proofs, 2-column algebraic proofs. Make sense? You're going to just work out an equation using 2 columns, that's all. Make sense? Okay, I'll stop here, guys. I'll see you next week, but I'll post the homework from a different assignment, okay? Any questions for me? What, ma?
Oh, nothing. Bye.
Yeah, bye. You're going to do part 1 and part 2 in the assignment that I'm sending.
Okay, bye.
Bye, guys.
Bye.
Bye, guys. Sabrina?
அதெல்லாம் அதுக்கு இதுவாக இல்லைன்றது ஒன்றும் ஐஸ் பேக் இப்போ வச்சோடனே பரவாயில்லன்றது. அதனால தான் ஏதாவது வேணுன்னா ஒரு ஹாஃப் டோஸ் ஆக்சுவலாக குடிச்சா கடகடன்னு கால் படையிறதுனா சரியாயிடும்டா.
நாளைக்கு முடியலன்னா லீவ் எடுத்துடுடா.
நிறைய நேரம் தூங்க ஆக்சுவலாக கொஞ்சம்
நிறைய வாக்கிங் போகணும். அது நல்லதுதான் பேபி, கெட்டதா எனக்கு ஆனா நீ போட்ட பிரஷர் இல்லையே.
திருப்பி தூங்கணும் இன்னைக்கு ரொம்ப சீக்கிரம் நான் சொன்னேன். இப்போ உனக்கு நைட்டு தூக்கம் டிஸ்டர்ப் ஆகாம தூங்கணும்னா ஆக்சுவலாக வேணா
அது சின்ன பொண்ணு தானே, நான் பிடிச்சி விடுறேன்டா. அம்மா உனக்கு நல்லா இருக்குமா? உனக்கு புரியலமா? எங்க வலிக்கிறது? எவ்ரிவேர் தானே.
ஐஸ் பேக் வச்சுருக்கு பார்த்தேன்.
எங்க ஐஸ் பேக்? அதுதான் அது தெரிஞ்சது வரேன்.
This thing is a hole in it. It's just going to all come squirting out of you. This thing actually doesn't work.
பார்க்கவே இல்லை. சரியா இருக்கா? சரியா இருக்கா? அந்த காலம் கட்ட, அந்த காலம் வலிக்கிறதுனா?
See, this is one of those days when I actually want that massage.
ஏன்னா எனக்கு டெய்லி பண்ணி விடுறதா? நான் சொல்றேன், ஐயோ நீயே இப்படி எனக்கு நிறைய பண்ணி விட்டேன்னா நான் கடனாளி ஆயிடுறேன், நான் உனக்கு பண்ணி விடுறேன்.
Yeah, and I always run away screaming except today.
I know.
அது எதுவும் வேண்டாம்னு ஆக்சுவலாக இது வெறும் ஒரு ஆரஞ்சு சாப்பிட்டது அவ்வளோதான்.
I haven't brushed it.
ஐயோ வேண்டாம்.
பரவாயில்ல, ஆனால் உனக்கு பசிக்கலையா? வேண்டாமா? ஆனால் சூடாக ரசம் சாமும் நல்லா இருக்கு.
Please. Did you already prepare it though? But if you already prepared it, I'll eat it.
என்னடா ப்ரிப்பேர்லாம் பண்ணலப்பா.
I like you. I